Okay, welcome to our presentation. My name is Jason Bott. I'm the team lead for Longhorn Geothermal. Um, yeah, I guess why don't we go ahead and everybody quickly introduce yourself?
Sure. I'm Lucero. I'm a geophysics student at UT and I worked on some of the geofires and economic feasibility stuff.
Hey, my name is Nico Wooters, and I'm a geoscience student at UT as well, and I worked a little bit on the geology.
I'm Adam Kinney. I'm a environmental science student at UT as well. I worked on some of the stakeholder information and the environmental impacts.
Okay. So let's get started. First let's start with direct use geothermal energy. So what is direct use geothermal energy exactly? Direct use geothermal energy extracts heat from below the Earth's surface to create heat critical infrastructure. So that's water towers, that's apartment buildings, that's greenhouses. And you could go into the nuances all day, but essentially the system boils down to, no pun intended, um, injecting a geothermal working fluid downward into the ground, and then the high underground temperatures will heat the fluid, and then you pump that hot fluid upwards toward the surface, and that heat from the fluid is extracted and it's used to directly heat something. So you're not generating any electricity, you're directly using that heat from the fluid. And now we're going to talk about our site selection. So Presidio County, Texas. Why did we pick Presidio County? So first of all, Presidio County is located in that southwest corner of Texas, kind of over by Big Bend, relatively close to El Paso. I mean, relatively. Everything's so huge in Texas, so um, relatively is a tricky word to use sometimes. But it's located in that southwest corner of Texas, very rural, very deserty. So one of the first reasons we picked this county was because of strategic railroads. So any kind of project we want to make, the logistics of that, getting supplies from one way to another, if we want to do any food infrastructure or anything like that, it's going to be easy to transport things. Secondly, it has a history of renewable energy projects, and the county is very pro energy renewable energy projects. They have the a, I'm not going to try to pronounce it because I'm going to get it wrong, but they have a solar farm and a molten salt battery there. They also have a declining population. Around one third of the county is without health insurance, and they have a dwindling workforce. So there's very much an existing need for development. And they're also very close to the Permian Basin. So that's all these huge oil and gas companies, Oxy, Exxon, Schlumberger, all these companies are here. So that means drilling expertise, a demand for CO2, and existing drilling infrastructure is close by.
So I'm going to talk a little bit about the geology of Presidio County. So where we are located, we're located in Marfa, Texas, and that sort of is the southern portion of the Basin Range province, which is an extensional system, which leads to crustal thinning, which is sort of where we see a lot of our geothermal potential. It's also home to the Trans-Pecos Magmatic Province, which is a series of like volcanic centers located. If you've ever been to Big Bend, that's a big part of it. And there's also multiple basins, including a very small portion of the Permian Basin region. So actually kind of looking at the rocks within Presidio County, there's four distinct age groups that we can sort of see here. There's Precambrian, Paleozoic, Cretaceous, and Tertiary. If you look at the cross sections here, Paleozoic and Cretaceous are kind of lumped together because they're both kind of like these carbonates and sandstones. But the Tertiary, which is our most recent level of rock, are the volcanic rocks from the Trans-Pecos Magmatic Province that we talked about a little bit earlier. And the pink rocks are the Precambrian basement rocks, which is, if you look at the border region here, that's where we're getting a lot of our geothermal reservoirs, right? So at 2,500 meters, we're getting 150 Celsius, and that's mostly composed of granites. Where we're located in Marfa, Texas, that's the interior region, and we'll see about 150 Celsius at about 4,700 meters. So actually, in regards to their potential for geothermal, we can see that the regions closer to the border exhibit a higher heat flow, which is due to that shallower basement, which has resulted from that basin and range crustal thinning. Where we're located in the interior region, closer to Marfa, it's a little bit less heat flow than the border region, but it's actually still higher than average. As we can see here, the interior region has a heat flow of 95 milliwatts per meter squared, whereas the border region has a heat flow of 155 milliwatts per meter squared. Now, this in general is very good for geothermal because this is higher than the world average continental heat flow, which is 71 milliwatts per meter squared. What we can take away from this is that our geothermal potential is quite high. So if we look at the interior region where we're located, we can get about 150 degrees Celsius at 4,700 meters, which is ideal for greenhouse heating, which is exactly what we're going to try and do here in this project.
Okay, so on the subject of greenhouses, let's talk about a little bit about Presidio's greenhouse problem. So CO2 enrichment in greenhouses is a long-standing practice and it's also heavily researched. If you go on Google Scholar, you'll find paper after paper talking about optimizing CO2 concentration. Essentially, that's increasing the amount of CO2 inside of the greenhouse environment in order to boost plant productivity. You know how plants use CO2 and sunlight for photosynthesis, right? CO2, water, and sunlight. That being said, the price of CO2 through time has been increasing, especially since 2020. You can see a big increase here. So this is the price index from the Federal Reserve over over the last couple decades. And you start to see an increase in 2005 and then just a huge spike in 2020 around like 2020, 2022. And so what this is doing, or I mean, as the price of CO2 increases and shows consistent long-term growth, it makes it difficult for greenhouse companies to directly purchase CO2. And so Village Farms, a huge greenhouse company with a location in Presidio County and one of Presidio County's largest employers, they have to burn natural gas to stay in business. They can't buy they can't directly buy CO2 and use that to enrich their greenhouse environment. And so our solution to that problem is saying, okay, why don't we use an enhanced geothermal system here to not only provide heat to the greenhouses, but also provide heat to a solid uh, direct air carbon capture collector in order to supply both heat and carbon dioxide. And then any extra carbon dioxide you can sell to, proximal Permian Basin oil companies. You can store for tax credits, et cetera, et cetera. And so with this EGS system, I think the big takeaway here, especially if you're new to geothermal, is that normally in geothermal, you're injecting fluid down and that fluid comes back up. And you're taking advantage of already porous rocks. So there's already a lot of space in between the rocks for that water to kind of move around and heat up. Here, what we're doing is we're stimulating fractures. So it's fracking in a sense, right? We're opening up fractures, we're creating a fracture network inside of the granitic basement rock. And that really maximizes the surface area and that fluid to rock contact. And so can get a lot more heat out of your fluid. And so as that, cold fluid comes down, and the hot fluid comes up, you're getting a lot more heat. And so solid sorbent direct air capture, what that looks like is that you're pulling ambient air through through with a fan through a solid sorbent, so something that can absorb CO2. That CO2 free air moves out, and that sorbent collects the CO2 over time, and then whenever it's ready, it needs to be heated to around 100 degrees Celsius. And using the hot geothermal fluid, we could do that. And then with that concentrated CO2 that we collect, we could route that to the greenhouse or store it for, selling or storage later. And there's some pretty famous facilities that do this. So there's the Mammoth facility in Iceland, and then there's the Orca facility. They don't work with greenhouses, but they are state-of-the-art direct air carbon capture facilities. And that geothermal that any excess heat from the geothermal plant could be routed, like I said, to the greenhouses themselves. And the most optimal routing path would be this site 2 towards the greenhouses here, which would be about 360 meters.
So I'll be talking a little bit about the economics of this project and some of the grants and loan stuff that would be going into it. So first off, we've got the Inflation Reduction Act. The Inflation Reduction Act was passed in 2022. Most importantly, it would include an investment tax credit of 50% for investing in clean energy. We've also got the REAP program, which funds agricultural producers in implementing renewable energy methods in their agricultural processes. And some Texas wind and solar tax credits that would negate property tax with the integration of wind and solar in our geothermal processes. So a little bit about the Inflation Reduction Act. It funds the transition to a clean energy economy, and it includes investment tax credits and production tax credits, including an IRA investment tax credit of 50%. There's also a 6% tax credit for the installation of a geothermal heat pump. And additionally, there's some carbon credits under section 45Q that's in some of our references in the paper, which includes a credit of $130 per metric ton of carbon. The REAP program stands for Rural Energy for America program. It offers loans and grant funding to support agricultural producers implementing renewable energy systems. It can guarantee funding up to 75% of total eligible project costs, up to 50% grant, and up to 70% loan. As for Texas wind and solar, Presidio County property tax currently amounts to 0.5%, which is already a third of Texas average. But this property tax could be completely negated with the integration of on-site solar and wind devices. This could actually be pretty useful for our systems. It could be used to provide electricity for the greenhouse's light, pump, and fan needs. A little bit about the capital expenditure of this project. Assuming no grants or loans, how much would this cost? It would be around 62 million. Including a 46% ITC, which would include just the IRA benefits. It drops down to around 33 million. If you include the IRA and a 25% grant from the REAP program, it drops down to 18 million. And if you assume a 100% ITC in the scenario where some of the money would likely be loaned, resulting in no upfront cost, but costs later down the line, of course, you would get around a 0 million capital costs. But this would be under the pretense of a loan. As for operational expenditure, it remains the same for all scenarios. The total operating and maintenance costs would be around 2.03 million a year.
So here we have our community stakeholders. This is going to be a map of our stakeholder analysis. It largely breaks the stakeholders of this project into different groups that are relevant to different parts of the process. You'll see the academia group. This is largely the University of Texas at Austin, who's going to carry out some of the research involved with this, as well as a subset of the University of Texas, which is the Bureau of Economic Geology, who provide a lot of information in the Presidio Geothermal assessment report that was very integral to our project. Then we'll have different industry stakeholders. These are going to be utilities who are providing water, power, and transport. to help with the actual fabrication of the geothermal project, as well as contractors who will help too. These are ranging from big contractors in the Permian Basin to local contractors in Marfa and Presidio. And Exceed Geo Energy is considered a consultant, as they are another geothermal company pursuing a project in Presidio. Village Farms is our primary off-taker, as you've heard much about. They'll be receiving the bulk of our energy and carbon production. Uh, the political entities are the county and the city of Marfa, and we also spoke to Tony Gonzalez, who is the current representative for the 23rd Texas Congressional District. They informed sort of the political climate around the project. The administrative bodies at the federal, state, and local level all provide different regulations and standards for different industries and products that relate to this geothermal development, whether it be land usage, environmental quality, water quality, agriculture. They all touch on different parts of the process. And then we also have some public groups who will help support this project. We have the Texas Geothermal Energy Alliance and Geothermal Rising, who are both uh, pursuing action to further develop the geothermal technologies, and then some other associations who relate to local environmental impact in Presidio, as well as energy authorities in Texas, and also brewers groups who may help offtake some of the greenhouse products.
And a small correction there. We have not talked to Tony Gonzalez, but I have been in contact with people from his office, so that would be a future plan, but not something we've done yet.